Welcome back, and we're going to look at exponential and logarithmic functions and their graphs now. So we've kind of seen the exponential function graph before in the introductory video. But what does a log function look like? So we want to be able to graph an exponential function and a logarithmic function on a same graph. How do we do that? Well, okay, surprise, surprise, start with the table of values. So if we look at x and then 2 to the x, right? We get minus 3, minus 2, minus 1, 0, 1, 2, 3. This is from an earlier video, and so we end up with 1/8, 1/4, 1/2, 1, 2, 4, and 8. So when we graph it, we get, this, and then this, and then that, and let's see, plotting this, we get something like that, and this, and like that, and so on and so forth. So we get something that looks like this for f of x. Okay. Now to graph g of x, the biggest thing I'd tell students is remember, play off the inverse relationship. So for x and log base 2 of x, right? Find the corresponding exponential functions and we'll flip the columns. So then we'd have x is 1/8, x is 1/4, 1/2. 1, 2, 4, and 8, and then minus 3 for the y, or for log base 2 of x, minus 2, minus 1, 0, 1, 2, and 3. Okay, so now I'm just going to plot these points. That one, yep, 2, 1, 4, 2, 8, 3, and then we get something like this. So there's our function g of x, okay? And certainly we remember that inverse functions are also symmetric about the line y is equal to x. So that's the line, and if we fold along that line, yeah, they look kind of like mirror images. Great. I did a decent job of graphing. Oh, and well, okay, decent, not perfect. I need to add arrows on both of these ends, okay? So that's fine and well. This is what a graph of a base logarithmic function looks like. Okay, so but of course we can't have it that easy. We can transform these things too. So now we have the function 2 to the x minus 3 minus 4, and we need to be able to graph it. That's number one. As I said, find the domain, range, and any asymptotes. Okay, so I want you to start with that 2 to the x function, and then there's going to be a couple transformations. 2 to be precise to get you to 2 to the x minus 3 all minus 4. And so tell me what those transformations are. And actually, so if this is our base function, right? Actually, let me do this in another color. I'll do the base graph in black here. 3 and then 8 about there, and then boom, boom, boom. Okay, if this is our base function, I want you to graph this whole thing and get us to the end. Okay, so pause video, try it out. Okay, well, I'm going to show you the completed graph. Okay, ignore the domain and range for now, but this is what it looks like. All I had to do was recognize that I shifted right 3 and down 4, and so I took each of the points right 3 and down 4, and got my final graph. Okay, so let's talk through the domain and range. Domain, that actually doesn't change. So the domain, I didn't alter x, I didn't restrict x at all, I just shifted it. Okay, minus infinity to infinity. Okay, the range, originally it would have been 0 to infinity, right? But, well, that was for the base graph, but what I ended up doing was shift it down 4, so it's actually not this, but we have to move it down 4 to minus 4 to infinity. And so that's consistent with our graph here, because if we look at this line here, this is the y is equal to 4 line, or negative 4. Yeah, and that should be a minus 4. We approach negative 4, but we never fully reach it. Okay, so there is our range. And then consequently, because our range approaches negative 4 but never fully reaches it, we would say we have a horizontal asymptote at y is equal to minus 4. Okay, So that's that one. Well, we did the graph of an exponential. Better do a graph of a logarithmic. Okay, so now this is transforming the log base 2 function that we had up top, so you can work from that. I'll kind of, again, provide you the base graph. And let's see, 3, let's see, right there, and then 8, that one. Okay, and then boom, 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 something like that. So if this is our base graph, right, I think there's actually 3 transformations going on here. You may want to write this as minus x plus 3 to make your life a little bit easier. So you'd begin with log base 2 of x, then you have a transformation, another transformation, and then a third one before you get to f of x, that final function. Okay, the order is important. Try it out and then reflect it in the graph. Okay, well, there's 3 things here. There should be first a horizontal shift left 3, that's the plus 3. Then there's going to be a horizontal reflection. And these last 2 technically can go in any order, reflection over y-axis. And then the last thing is a vertical scale by factor 2. Okay, and again, I'm not going to sketch it out, but I will show you the completed graph here. And so this one, there's a little bit more to it. So I started with green being my base function, and then I shifted it left 3 in blue, and then reflected it in red, and then finally the purple one is the final answer. Okay, and as you can see here, the domain range and vertical asymptote are all listed. The range is the easiest one because, again, you would just say for the exponential, the domain was all real numbers, so now the range for the inverse function, the logarithmic function, is going to be all real numbers. And the domain, that one you might need to do a little bit of work on. I did it mentally by taking the input, right? We talked about this in an earlier video. Take the input, set it greater than 0, and then solve it. So 3 is bigger than x, or written differently, x is less than 3. So then that's how I got the domain. Okay, I did that in my head. Okay, consequently, when I restrict the domain, I say, oh, I can get pretty close to 3, but I can never fully reach it. That's the idea of an asymptote, and so that's where I get my vertical asymptote. Okay, so that's going to complete this video. We're going to get a lot of practice with graphing and identifying domain range and asymptotes, so be ready.